Hello, this is Mrs. Ross, and we're going to walk through 5.4.2 Newton's Law of Gravitation quiz review. Okay. So here we have two 1 kilogram point masses, distance d apart, which exert a gravitational attraction F on the other one. If 1 kilogram is added to each mass, so we have 2 kilograms, the gravitational attraction exerted by each will be blank. So what I did was I drew this. This is 1, this is 1, this is my distance. And then, so that's my first scenario, and my second one, I'm going to add 1 to each side. So in the first scenario, I'm using this. Which is going to be g times 1 over d squared, which is equal to g over d squared. So this is the first scenario. In the second scenario, I have the same formula, but I'm going to plug in 2 instead of 1 for my masses. So the answer is A, because of this. Okay, number 2. This was kind of a tough one, so I'll show you what I did. So it says each mass is 3 kilograms. Find the magnitude and direction of the gravitational force on A. So I drew a free body diagram-esque. Okay, so I have the force of B on A, and I have the force of C on A. And then it gets interesting because this is going to be, I'm going to divide this in half and make this 45 degrees because I'm kind of bisecting that. Since this is a square, I'm bisecting this. And this is going to be sine of 45, or the force of D on A, sine 45. And this is going to be cosine, dA cosine 45, this side. So what did I do? Is that right? No, that's not what I wanted. I'll just keep going. We'll figure it out in the end. So I put FD. Actually, it doesn't matter. It's good. We're fine. Never mind. 45 degrees. This is FD on A. Cosine 45 degrees. So I'm adding up my forces, I guess you could say. And I know that the resultant is going to be in this general direction just because of the direction of the arrows. So I know it's going to be in the direction of D, so it's one of these. And so I went ahead and I summed the forces. I was like, okay, so I have the sum of the forces. I have FCA plus, oh shoot. Oh goodness. Sorry, I don't know what happened there. There we go. FCA plus, how did I get that number? Oh, because these are forces in the Y. Hold on. This took me like 2 pages to do, so, hold up, this is the one. Aha, here we go. Okay. So what we have is we have the force of B on A is equal to GM1N2 over R squared, which is 6.67 times 10 to the negative 11th. That's a constant, times 3 times 3 over, and this 10 centimeters, we have to convert that to meters. So this is squared. And this is equal to 6.01 times 10 to the negative 8th. This is also the same as FCA because it's the same distance and it's the same masses and all of that fun stuff. So that's FCA, FBA. So we have this one and this one. Now we need FDA. And what I did was I found this distance to be 14.14 centimeters. And I'll show you how I did that. So I said, you know, the radius from A to D is going to be equal to, basically I have 10 here and I have 10 here. So it's going to be the square root of 10 squared plus 10 squared using Pythagorean theorem. And I got 14.14 centimeters, which is 0.1414 meters. So I'm going to use that to find FDA. Same formula. So I have 6.674 times 10 to the negative 11. They're still both 3, but the distance is different. So I have this, and that's squared. So this is 3.004 times 10 to the negative 8 newtons. Okay, so I have everything that I need there. I'm going to erase a little bit because I need some space. It's not erasing. Why you no erase for me? Oh, I know why. Okay, because it was on the other thing and blah. Okay, then I'm going to change colors, and because there's still a lot to go. So if I sum of the forces in the y, which is right here, I am adding these two forces. So I have FCA plus FDA cosine 45 degrees. Okay, so this is 6.01 times 10 to the negative 8 from over here, plus this 3.044 negative 8 times the cosine of 45 degrees, which gives me 8.134 times 10 to the negative 8. These are my forces in the y. If I do my forces in the x, which are right here, I have FB, and they're heading in the same direction. That's why I'm adding them. FDA sine 45 degrees. Looks almost exactly like this. And I get the same number, actually. 8.134 times 10 to the negative 8. And that's my forces in the x. And then to find, I'm losing room here, so sorry. To find my resultant force, I'm going to do this. Okay, so I'm going to plug this in to here, and this in to here. The only reason I'm not writing it out is we're going to lose our question here in a minute. But, and I got 1.15 times 10 to the negative 7th newtons. So that's going to be this one. Okay, let's see if I can use less room on this next one. We'll see. So I have a couple of astronauts agree to rendezvous in space. Their plan is to let gravity bring them together. Astronaut A is 65 kilograms. Astronaut B is 72 kilograms. They start from rest 20 meters apart. What is the gravitational force between them? And this is the constant. This is a straightforward use of this formula. So we're just going to plug in what we have. 72, because those are in kilograms. Those need to be in kilograms. This is already in meters. And I get this, which is this. Okay, number 4. Okay. So we have an 8 kilogram point mass and a 15 kilogram mass held in place by 50 centimeters. Okay. Particle of mass m is released by a point between the two masses from the 8 kilogram mass. Okay, find the magnitude and direction of the acceleration. Okay. So I drew a picture because I kind of need to see this. So this is 8, and here's 15, and this is 50 centimeters, which we're going to have to convert to meters. And then when I let the other mass go, 15, it's here, and this is going to be 20, and this is going to be 30 centimeters. So what I did was I said, okay, the force of gravity on the 8 kilogram mass here in scenario 2, same formula we've been using. So same gravitational constant. I have 8, and then I just made m the other mass. And then r squared is going to be 0.02 because it's got to be in meters, and I end up with 1.33 times 10 to the negative 8 m, because we don't know what that mass is. I did the same thing for the 15 kilogram mass. So this is 15 m over, and the distance is 30 centimeters, or 0.3 meters. So I get 1.11 times 10 to the negative 8 m. Okay. So now what I'm going to do, since they are in opposition, or opposite directions, my total force is going to be my force of gravity on the 8 kilogram mass minus the force of gravity on the 15 for the force on m. Okay. And what I did was I plugged these in, 1.33 times 10 to the negative 8 minus, because m would be in all of these, I can cancel it. And 1.11 times 10 to the negative 8. And I get 2.2 times 10 to the negative 9 newtons. And I know that it's going to be in the direction, see, if this is the positive direction towards 8, so this is the positive direction, this is the negative direction, it's going to be towards the 8 kilogram mass, which is C. Let's see if I can get another one done. Oh, this one's a tough one. I mean, we can do it, but it's not soups easy. So let's see what we got here. Your spacecraft lands on an unknown planet. To determine the characteristics of the planet, you drop a 1.3 kilogram wrench from 5 meters above the surface and find that it hits the ground 0.811 seconds later. You know the circumference. You know circumference is 2 pi r. Just kind of saying. Is this, and this is in kilometers, and we're going to need to change that to meters. What is the planet's mass? Okay, so first things first, let's find our radius using this. So I have 62, 400 to 3.14 times r, and r is 9936.3 kilometers, which is equal to meters, which I put into scientific notation. There. Let me change colors. I don't know if that's going to be helpful. We'll see. And then I solved for the acceleration of gravity using one of our kinematic equations. So we have x is equal to VOT plus 1/2 AT squared. It says that I'm assuming that VO is 0. So this is going to be 5. 1/2. I'm solving for A. My time is this. So if I scratch all of this out, I get A is equal to 15.20 meters per second squared. Okay, and where did I use that? Good question. Oh, I see. So sorry. So, oh gosh, we only have 30 seconds. Here we go. I might have to come back to this, but there's a formula in 5.4.2 where you can use this to solve for, and I think that this is in G, and I'm going to have to stop this. Hold on, we're going to do this in just a minute.